All right, chapter 7. Chapter 7 is going to be bone tissue. In lab right now, you're already an expert, right? You're already an expert in bones. But what we're going to be talking about in chapter 7 is the physiology of bone. And so we're going to be talking about both starting out with just a little bit of anatomy of a bone, and then we're going to talk, after that, we're going to start talking about how bone is formed and the role that it plays. Bones actually play a significant role in other physiologies, actually. So anyway, let's just go on and get started. I'm back since we have a holiday tomorrow. Normally, I probably would have done this at school tomorrow, but I'm at home on Mondays, as you know. And so as a result of that, I'm going back to my little tiny whiteboard and going to try and use it to talk about these slides like I've done in the past on occasion. All right, so I've got a generic bone up here. And so you can see when you think of, sort of the classic way that a child might draw a bone, that's what I've drawn on the board. And you can see here that at either end, you have an expanded portion. And the scientific name for that is an epiphysis. And then in between, we have the shaft, and that's called the diaphysis. And so when we talk about a bone, we have these ends, and at either end, both ends are the epiphyses, and then we have the shaft in between that we said is the diaphysis. Now, how does a bone grow? So if you think about it, it's calcium phosphate. It kind of reminds you of a rock or concrete, right? So how on earth could something like that grow? And the answer is the bone itself doesn't grow, but you have cartilage that grows that gets converted into bone. And so when we start looking at this bone, in the epiphyses, in these upper ends of the bone, we have what we call the epiphyseal plate. And so we have one here, one here, one here, and one here. And you and I, maybe you've known someone who had a shorter leg, or someone who had an injury and they were worried about the bone stopping growth. And what they said to you was, oh, they had a fracture in the growth plate. That's what that is. So the epiphyseal plate is a region of cartilage that expands, and then it gets converted into bone. And that's actually how bones grow. So we have, in each of the ends, we have epiphyseal plates, and those are cartilage. And when you get older, so if I was to ask you, how much taller do you think you're going to be, maybe 10 years from now? You'd say, I'm not getting any taller. I'm through growing. And so so I bet you never thought about what does that actually mean with regards to these long bones like this. Well, what it means is that cartilage, that epiphyseal plate, got converted to bone. And once it becomes converted to bone, and it's no longer cartilage, we call it an epiphyseal line. So in any given long bone, like we have drawn up here, you're either going to have an epiphyseal plate or you're going to have an epiphyseal line. So what are some other characteristics of bones? Maybe you love steak, and you go to the Golden Corral or to Longhorn Restaurant or some other restaurant, and you always get a sirloin steak. And there's that round piece of bone in there with the hole in the middle. That hole in the middle, it's an opening down the middle of the bone. It's called the medullary cavity. And what's inside of it? Some people love to eat it. Yellow bone marrow. It's a fatty bone marrow. Now, we'll be talking here along the way. We'll bring up another kind of marrow. It's red bone marrow. But now in the medullary cavity, we have yellow bone marrow, and it's a fatty material. And these, cuisine type people, they say fat is flavor, right? So that's why people like it. So we have the medullary cavity, and this has, not only does it have the yellow marrow in it, it has blood vessels and nerves. It ends up, bones are highly vascular. That means they have a lot of blood vessels, and they have a lot of nerves in them. If you've ever broken a bone, it hurts. That's because so it's not just like a brick or a rock. There are blood vessels and nerves that extend out from this medullary cavity into the bone matrix. So we have our two ends of our bone, the epiphyses. We have the shaft of the bone, the diaphysis. We have the medullary cavity down the middle. And one of the things I will show you, try to remember to show you in lab, is some of our real human bones that we have in there. And usually, and these are, of course, from people that gave their bodies to science or sold them or whatever, but we end up with it. And they're usually old. And so what happens is you sometimes can see in the ends of the bones this it looks like little beams inside of there. And this is something we call spongy bone. And so it's kind of like, rather than being a solid bone, and by the way, that solid bone is called compact bone. And so the sides of the shaft of the bone are made of compact bone, and the outer surface of the bone is covered in compact bone. But in the epiphyses, in the ends, we have underneath that layer of compact bone, we have spongy bone. And amongst those little beam-like structures in there, we have red bone marrow. And it's nothing to do with fat or flavor. It's where blood cells are made. Red bone marrow is found in the proximal ends of some long bones. That's what we say. And it's where red blood cells are made. So that's going to be one of the functions of bone that we'll talk about. So we have the spongy bone. There in the epiphyses, we have compact bone along the diaphyses. We have a medullary cavity. We have the epiphyseal plates or lines at either end. Oh, there's two more labels up here. There is the periosteum. Now, hopefully you can figure out what I've drawn on the board there. That's a connective tissue layer on the outside of the bone that I've kind of expanded so you can see it. And that's called the periosteum. Then we said we have this medullary cavity that's filled with yellow bone marrow, but lining that interior, we also have a connective tissue layer, and it's called the endosteum. One other thing I just remembered that I didn't put on my label, where bones come together. So if you think of, the femur coming in contact with the tibia, right there, you might think, well, gosh, the bone rubbing on bone, how long can that last? You know, you would think that you would have a lot of damage, and sometimes you do. We call it arthritis. But in a normal functioning interaction, this what we call an articulation, you have what we call articular cartilage covering that surface, which allows it to rub back and forth. So that is one other thing that I needed to mention, and I'm taking a quick look at my notes. By golly, I think we have covered everything through through slide 5. Okay, I think we've covered everything through slide 5, so I'm going to stop right there. If I think of anything else, I'll add it to the next video.